right, hi everyone. Thanks so much for having me. My presentation is about what's next. So we're talking a lot about 3D printing, also known as additive manufacturing, but this isn't really where it ends, and a lot of people are already speculating about what we'll be looking to in the future. So as a bit of my background, as already mentioned, I'm in a program called the Teal Fellowship for the class of 2013, and I work in the wearable technology space. We look at second generation wearable technology, so more in the enhanced apparel space. And this is an example of a project that I worked on at the School of Visual Arts. It's called Zygomatic, so it's a shirt controlled by a processing interface. You press buttons and the shirt changes shape. So looking at modularity in garments, playing along with electronics and clothing and shape. So regardless of what I'm doing, I tend to like this idea of let's go after the dark matter and see what we don't know already. And whether that be in additive manufacturing or in wearable technology, there's always something that we haven't explored but should probably be explored. And as mentioned by people like Paul Graham and Richard Hamming, there's this emphasis on the idea of solving hard problems. So when something has been solved and we have an answer, I think it's time to delve into something that we have no idea about and really need to get more answers on. So I had the pleasure of going to Autodesk for 2 months and doing research with their 3D printing team. So they built a stereolithography machine, which is a type of 3D printing, and I did a bunch of swatches in order to see how we could get different finishes from this machine. So rather than post-processing finishing, what I did was write code that would generate individual layers for the printer, and so when you print it, it comes out looking either clear or matte. It's a little hard to see in the projector, but the idea is that you can print them having different surface finishes using code. So this was kind of cool. Nobody on the team had done this quite yet, and I was thinking, if this hasn't been done, what else hasn't been done? What are we not talking about? So I always like to look at Gartner's technology hype cycle, where we have the peak of inflated expectations for anything, and then a productive future. So what is a productive future for 3D printing? I'm really not sure. It's hard to plan the future, but I think it might have something to do with molecular assembly. So this is a replicator, like from Star Trek, called a molecular assembler. And MakerBot's 3D printer is also known as the replicator. So what is molecular assembly? As said by Eric Drexler, it's a proposed device able to guide chemical reactions by positioning reactive molecules with atomic precision. This basically means that we put together atoms and molecules to make matter from the very origin. And so in looking into any new field, we have to ask the important questions, of course. So what is the language? What are the predictions? Who are thought leaders? What are the problems? And only when we look at all of these things can we really start to understand and tackle what's at hand. So starting with language, we of course have the replicator, but this machine is also known as a Santa Claus machine. Mind you, it doesn't exist yet. So there are a lot of different people speculating about it, anyone from like comic geeks to Star Trekkies. And so looking at the thought leaders in the space, we have people like Eric Drexler, and Richard Feynman. There are two very popular texts. One's called There's More Room at the Bottom, and the other's called Engines of Creation, that speculate about what might happen. But both of these do fall quite a bit into chemistry, and we see a bottleneck in chemistry itself because our goal is to create matter, and this is a chemical problem that's fairly challenging. And in the world of chemistry, it's known as automated organic synthesis. However, our ability to use nanotechnology, whether that be for chemistry or on a more mechanical level, is kind of like playing with Legos with boxing gloves. As you can imagine, it's not very elegant and it's not precise whatsoever. So this is an example. Unfortunately, it's a little dark, but of trying to mechanically play with nanotechnology. So it's a grain of salt ingrained with a bean in order to get this eye. And this is an attempt to kind of etch away mechanically at matter on a really low level in order to manipulate it. And then on a much, much higher level, this is a machine from the University of Illinois that's been able to assemble 14 molecules, only 14 molecules, as an advancement in molecular assembly or automated organic synthesis. So anyways, we see what's happening, and then we get to the theories, right? So there's a theory of market impact for something like this. 3D printing a duct costs $10, and injection molding costs $1,000. What will molecular assembly be? And then on the other side, you could see an image of nanofactories. So these factories that build smaller factories, that build tiny factories. And there's speculation that the tiniest factory will lead to something called gray goo. This is an assumption by Eric Drexler as well, that these small factories will get everywhere. So anyways, this is a bunch of speculation. But the question is, what's next? I don't know, maybe some of you guys know, but if you're interested, the Foresight Institute is really looking at nanotechnology and molecular assembly to find out what a productive future is for this category. So thank you for your time.